So one issue that came up over the last week was more of a vector issue, but it's an important one in QGIS, so I thought I'd cover how to handle that, and it has to do with invalid geometries. Let me share my screen and bring up QGIS here. So I'm sure anyone who starts doing analysis in QGIS will see this eventually, and it has to do when you're running usually one of the overlay operations in QGIS against vector data. So this could be like a clip or an intersection or a union or a difference operation. You may end up with this message that says one or both of the input layers have invalid geometries. And another related message you might see is that the GEOS processing error, that the intersection failed. And they're both related. Essentially, QGIS uses this GEOS library for performing all of these overlay operations. And GEOS is really part of this thing called the Java topology suite. And these are used for these sorts of operations in pretty much every open source GIS application, such as PostGIS and Google. And so these issues come up, and there has been recently an improvement in that. It was just last year where this company Crunchy Data, which employs one of the developers of the JTS topology suite, gave him the time to improve and rewrite some of the code to improve that. And so there's an article here that he posted about that I'll put in the chat in case you're curious about some of the details of that. But when you'll see that in QGIS, it kind of stops you from running an operation. And for one thing, there's a setting in QGIS. So if I go to settings, options, and go to the processing tab, in the general section, there's a setting for invalid geometries. Where is it in here? I don't know if people are aware, these are kind of often overlooked too. And almost every window in QGIS, there's a little search box here that you can use to filter the results. So in this settings options window, if I forget where invalid geometries are, I can just start typing invalid and it will filter my GUI until I can find it. And so here, invalid feature filtering, it's set by default to stop algorithm execution when a geometry is invalid. And there are a couple different settings here. You can choose to skip those features or do not filter for better performance. So which would just, again, let it run. So it's good, I think, to have this as the default, because you certainly don't want to run an analysis with invalid geometries and then or skip them, because it will obviously impact your results. So I think this is a good default. But when you get that message, there is a fairly easy fix that you can run. So if I was getting that result when I was working with clipping the final result poly against my suitable soils, for example, I could repair the invalid geometries fairly easily. If I search in the processing toolbox using the keyword fix, there is a fix geometries algorithm in here. And you can certainly run this fixed geometries algorithm against, for example, the soils data set, and then it would output a new soils data set with fixed geometries. But there is a more elegant way to use this tool. So if I clear my selection here, there is a feature that I think also gets kind of overlooked in the processing toolbox called edit features in place. And what this does, if I click this, it filters the algorithms in the processing toolbox for those that can be run in place. And in place means that it will repair, if I run fixed geometries against suitable soils, it will repair the geometry to that shape file without having to produce a new output. And so there are several, quite a few tools in here that can be run that way. You can even run, if I go into vector overlay, I can even run things like the clip tool in place. So you could clip a layer without producing new output. You're just changing the input layer itself. So there are obviously advantages to producing new output, so you still have the original, but in some cases it's also more convenient to actually run a tool in place and not have to produce copies of a layer. And so I think one of the best use cases for this is the fixed geometries tool, because I can simply highlight my suitable soils, for example, and with edit feature in place set, if I just double click this, it will fix the geometries. And I may have, do I have a selected set there? Oh no, it's only one polygon. Yeah, so one feature was fixed. And I could, it puts it into edit mode. So when you're done, you toggle out of editing and save your edits. And that will repair any issues with the geometries in that layer. And so you could do this to both vector layers that were part of that overlay operation, fix them both in place, and then you can just repeat. So if you run into that error, you can leave that clip operation open, go into here and fix the geometries on both inputs, and then in the clip algorithm, just switch back to that original parameters tab and run it again, and it will work. So that's the fix for running into invalid geometries. There are some other tools in here. If for whatever reason that doesn't work, there are some similar tools in the processing toolbox that people sometimes use. For example, in the grass tool set, in vector, there's v.clean. And v.clean can also be used to do a similar thing. It will clean up the topologies in a vector layer. And another trick people used to do was to buffer a layer with a value of 0. And that will almost typically will fix any geometry issues as well. But the fixed geometries tool being run in place is the way that I always use now, and it's works 99% of the time. The other thing that Anna brought up at the end of the last class was the issue with computing areas, and you get different results. Well, you'll get different results depending on which algorithm you use to calculate the area. You'll even get different results depending on which coordinate reference system your data is in. So a coordinate system like UTM that has big zones that run north to south is basically, the UTM coordinate system is a Cartesian coordinate system, meaning it flattens the Earth out onto a flat plane. And if you're dealing with a coordinate reference system that covers a smaller part of the Earth, and therefore less curvature has to be flattened to produce that Cartesian coordinate system, those coordinate systems will usually be more precise in determining an area calculation. So you can get different results in area calculations depending on what CRS your data is in. So that's something to be aware of. But I wanted to demonstrate the two main ways to calculate area so that you can see what the differences can be. So just for our study area polygon, I created two columns here. One, it's going to be hectares using the variable, which is the $area. And this one will be the way that Anna was describing, where you use the area function, feeding it the $geometry variable, and we can see what the difference is. So if I choose my variable field. I can just put in $area and update all, and I get the square meters of this. Now this is using the this isn't using the Cartesian plane, it's using the ellipsoidal area. If I use the other function, which is area, and I feed it the parenthesis, feed it the geometry of my features, like that, area $geometry, I will get a different result. You can see that they're both close, but there's actually a 4 hectare difference between these two. So it definitely matters how you calculate areas, so be aware of that. So thanks, Anna, again, for pointing that out. It's a really good point. And I wanted to point out.
Thank you. But just one question. You were saying that the first way you calculated, that was actually the Cartesian way?
No.
Okay.
So if I open up the expression window, there's a very good description of those two methods.
Okay, because I hope the second one is for the Cartesian area.
The second one is, yeah.
Ah, good. Then I misunderstood you. Good.
So the first one, if I do, if I search for, I'll just go into geometry. I find $area. So this returns the area of the current feature using the project's ellipsoid and the aerial unit. $area, the area function that you that you recommend and that your company has started to use. The calculations are always planimetric in the SRS of the geometry. So this is a safer way to go because it's always going to be planimetric, in this case in UTM.
Yeah, it was because sometimes we do the calculation using FME, and you're starting out getting different expression compared to what people do when they just use QGIS. So it's very important that you.
It is, and it can be
very to do the same.
It can be very confusing to a manager when two GIS people come up with different values for calculation of an area. So the other thing to point out, I showed you that there's the plugin for calculating geometry. And so I wanted to point out that the same two methods are available here, where we can use the Cartesian calculation using our UTM coordinate system, or we could do it using the ellipsoidal calculation. And so that you can, if you're using this plugin, you can still produce correct, you still have the choice in how you do it, and you can produce correct output, or output based on the planimetric CRS you're using.
And also, if you just grab the measurement tool, if you want to measure a distance, you also have to decide which one.
Yeah, that's a good point. Yeah, so there's the Cartesian and the ellipsoidal, and they will give you different numbers. So this also goes for calculating length of a road or length of a river. So yeah, lengths are also affected by this same issue. So yeah, so that's a really good point on all of that. So just, it's good to be aware of that. The other thing is that there are some other tools in here. I don't remember if I covered them or not, but if I go into raster tools, we have with the raster data model, these node data cells, which are usually areas Rasters always have to be square, for example. So if we have a kind of an irregular shaped study area, the raster will always generate our square raster, and any areas that we don't have data for will just be no data cells. And sometimes we want to have values for those noded data cells. Maybe we want to fill them with a value of 0 or something like that, for use in the raster calculator or something. So there is a fill no data cells algorithm that you can use to fill those, and it's very simple. You just point it to the raster and you specify the value that you want to fill those no data cells with. So if you ever need to do that, there is a tool for it. Another thing I don't remember if I mentioned is this tool Rescale Raster. This is another handy tool that we didn't need for this kind of sample analysis in the course, but is another commonly used way to manipulate rasters when you're doing an analysis. So Rescale Rasters, let's say we have I don't know, we could have a DEM, a digital terrain model, and we want to just rescale it so it ranges from 0 to 100. Or it might be, we might have an output of a model, and the values may have come in our case, from 1 to 4 or 0 to 4, and we would like to rescale that from 0 to 10 to put it on just a different scale. And so there is a tool for doing that, where you specify the new minimum and new maximum value, and QGIS will just do a linear stretch across the values, moving the values from their original range to your new range in the output. Sometimes this is done to put a whole suite of rasters on the same scale, in a similar way that we used reclassify to do that, to make 4 ideal for a vineyard and 1 not ideal for a vineyard. Sometimes people use Rescale Raster to do similar kinds of operations. There's also a round raster tool. So this allows you to round the values up and generalize the raster values. So that's also can be a handy tool. And then sometimes you need to do a raster analysis where you want to measure the distance from something, distance to roads, distance to hospital, something like that. And so in the Google tool set, we go into raster analysis. Here it is, proximity. There's a tool here called proximity that will output a raster that gives you, or the pixel value will be the linear distance in your CRS, in coordinate units, meters in our case, from the center of that pixel to whatever the object is. So this can be another important input for a model, is distance to something.
Is it only one at a time, or can you have several?
Yeah, this just well, it's proximity to to features in one layer.
Okay.
You can only run it on one layer at a time. So, and then the other thing is that I mentioned there's a model builder in QGIS, and so this is the model builder can be used for vector and or raster data, but it's very similar to FME, for example, has that kind of graphic layout of a process, and ArcGIS has the model builder. So this is very similar to those. So if we go to the processing menu, there's the graphical modeler here. And so this opens up a new window where you can drag inputs and put processing tools and string together a whole chain of processing operations. which results in a single tool that would do the whole analysis. So for example, if this vineyard analysis, if you wanted to replicate this for a site in Germany, we could set up all the processes, clipping the DEM, aligning the rasters, and all the steps we took to and create one processing tool that would just take all the inputs and click run, and it goes through the whole process. So that's a really, it's a nice environment. It's fairly intuitive to use. You have your different inputs. So for example, we could have a raster layer input, and we would give it a description such as elevation. You can describe if it's mandatory or not, and it plops this onto the chart. And then you might have a processing algorithm such as extract. And so we can, these are all the tools in the toolbox. Clip raster by mask layer. We could drag this in there and hook this up. Here's the inputs in Model Builder will be inputs that are already in the model usually. So we would choose elevation as the input. And as we go through this, we can enter a name for the output, which would, such as clip elevation. And click OK. Oh, there's another argument in there that it needed to me to fill in, but we get these the chain of tools lined up like this, and you can organize this as you need graphically. And if you ever need to go in and make a change, we can go back in. This would also need the extent, so we would have to go in and choose the mask layer. So for this example, I would need another input like a vector layer. And make this geometry type polygon. Click OK. And I'll go back in here and say that the model input is study area. I think that should be enough. Yeah. So we have our two inputs in the clip and then the output. And so then if I save this, I could so now if I close this and go into models in my processing toolbox, I have a vineyards tools set. And now I have this model vineyard that I set up. And if I double click on this, it asks for my elevation, which I don't think I have in here anymore. I removed it, but terrain aligned, and the study area. And there's the output that I could save, and I can click run. And it didn't really clip it because I already had it clipped, but you can see that you quickly have a tool that does that, and you can just build on that by adding each part of the workflow. So the model builder is a really nice environment whenever you have something like this that you need to repeat multiple times. So those are the things that I thought I wanted to show in this last session, but does anyone have any other specific questions or things that you ran into during your analysis?
No, I think I was doing all right. I did make a few mistakes during the exercise, but so I had to redo a few steps, but it worked out.
That's good.
And Stina and I was discussing the fixed geometry. I knew that one, but the second one you used for doing it on the shapefile and not getting a new shapefile. That was genius.
Yeah, I love that feature.
Exactly. I've been so ignored about how the layers I get. So I'll really go back and try that. And then, well, I should be challenging myself and look more into the modeling thing. That could help me some steps.
Yes, and it's something you can share with colleagues too. You can, provide someone a model tool like that, and then they can just use it. And there's some other nice little features in there. You can apply styles to the output so that when it finishes, the output is already styled in a certain way. You can also export those models out as Python scripts. And so that's really nice if you want to run it from the Python console, or if you just want to see how the QGIS Python API works and how things look. It's a nice place to start.
Was I supposed to have been sending the assignment to you?
Yes.
Before today? Oh,
No,
sorry.
no. You don't have to have sent it to me. Just send it to me by Monday, March 7th.
Okay, yeah, because I lost track of time. Sorry, time's running. Yeah, but yeah, I got it. I'm still not late.
No, you're not late. No, I wouldn't want to. I wouldn't require that you turn it in when we still have a question and answer session, because you may have had an issue that you needed to clear up before you could finish. So yeah.
Yeah, exactly. Good.
So yeah, get me your assignments by Monday, and then you'll be receiving the QGIS certificate for the course.
Cool.
All right. Well, thanks everyone, and I will send out this video as well, so you can have this to watch. And certainly, if you run into any questions between now and Monday on any of this, please let me know.
Okay. Thank you.
All right. Bye.
Bye.